Hey everybody, how are we doing? I went and got a haircut. Hopefully it looks good. Who is here? Is anybody in the chat? I'm like, no, it needs to be a little longer. It's all short now. It's all short haircut. That's the way it goes. So with that, we are here. We are going to do some work. What's going on my screen? Is my screen being weird? What is... That was weird. Look kind of weird. Let's go to the main screen, go check out a question. Let's do it. Okay, we're over here on the main screen. Let's go put this in the notes. Do some questions. Everyone's burnt out and we got tomorrow off, so people are chilling out. But we have here at the... Hey, Noel, good to see you here. Good morning. We will just click some points. Mubot is here giving out those points. Thank you for attending Mubot's birthday party. The presentation went really well. Stat 201, chapter. This is chapter 13. Homework. Question 9. Okay. So here's the thing. It was cool. Thank you. They really enjoyed the presentation. What are the 3 conditions if we are making a confidence interval for the true proportion? What are the 3 conditions if we are making a confidence interval for the true proportion? So you have to think, and there's a really good review video over this. It's one of the first ones. What are the 3 conditions? Random is random. Oh yeah, random. Random's the first one. Random. And then what after random? So I'm pulling up the video right here that has it. Under review 3, which you might even have review. I've done the review stuff post. We got it down here though. What are the 3 conditions? Really good review video right here. What are the 3 conditions to make a confidence interval for the true proportion? There's one proportion up there. So you got random. Random goes across all of them. Random means we have to randomly select the observations. What is the next condition? Random, we randomly select the observations. That is a condition. Randomly select the observations. What's the next condition? First condition is random. Randomly take the observations. What is the next condition? Microsoft Word still looks the same 5-6 years later. This was December 2019, I think. I went and visited my sister soon after making this video. What is the next condition? Watch on YouTube. What is the next condition? December 2019. So random is the first condition. We randomly select the observations. We have to meet that to be making a proper confidence interval. 10% and then success failure. There was like a pause. I don't know why. 10% and success failure. That is correct. There it is down there at the bottom. Success failure. Nearly normal will be if it's quantitative. So we have to ask, is it cat or quant? So when we go back here to the question itself, thank you, Noel, right there. You are correct. Random, we randomly select the observations. 10%, less than 10% of the population sampled. And we have at least 10 successes, at least 10 failures. How many successes do we have right now? Can you see up here? How many successes do we have? So how many successes do we have? Hopefully Mubot's not pausing now. How many successes do we have? How many successes do we have? How many failures do we have? How many failures do we have? You are correct. Keep those answers coming in. So we have 13 successes. How many failures do we have? Failure means non-conforming. So you need to be able to identify these things. I mean, you'll see I'll just click a right answer, and half the people are just going to click the answer and be like, oh, that's how easy it is. But it's like you need to know that we randomly selected these packages. Probably was done via random sample, so that's met. Are these packages of 25 less than 10%? 12, great job, Noel, yes. So do we meet random 10% success failure? We do, because we took a random sample. This 25 is less than 10% of all 25 of all red snapper packages. And then there are at least 10 successes, at least 10 failures. So that should be correct right there. So we meet all the conditions. Construct a 95% confidence interval. So for this one, you have to know the notation. It says construct a 95% confidence interval. You have to know the notation. If you do not know the notation, you're gonna have a bad time. And so when we do a 95% confidence interval, it's p hat plus or minus z star, and then square root p hat times q hat over n. So p hat is going to be x over n. This is x. This is n. So x over n equals p hat is 13 over 25 equals, that's going to be times, it's going to be 52%, I believe. So 0.52 equals p hat means q hat is equal to 0.48. Well, no. So the 13 is greater than or equal to 10, and the 12 is greater than or equal to 10. So you meet this right here because 13 and 12 are greater than or equal to 10. So remember, it's going to be the amount of successes, not p hat right there or q hat. P hat and q hat are not what are used. Technically, you would do n p hat. So the technical solve for it, which I'll put below this, is n p hat is greater than or equal to 10. And so you would take 25 times 0.52, which is equal to 12. Does that make sense right there? So it's technically n p hat. So it's right there. N p hat is greater than or equal to 10. I thought it would be a percent we were looking for. It'll be n p hat. So n right there, and then p hat is greater than or equal to 10. So you want at least 10 successes, at least 10 failures. So you have 13 successes and 12 failures, which equals up to the total n. So when you look at the size right here, you will get the total size is equal to n. So we do pass. Does that make sense? And then the 10% condition is that 25 out of the total population of n is less than or equal to 10%. So the 10% condition is that we have less than 25 of the populations, less than 10% of the population sampled. Does that make sense? The 25 over capital N is we've sampled less than 10% of the total population. So that's the 10% condition right there. The 10% condition is checked by doing, and we don't know what capital N is. We just assume they make a lot of packages, a lot of red snapper. So this is how you do the 10% condition down here. That is the 10% condition. And this right here is the success failure condition, which is n times p hat. Make sure to write these down, have notes on how to pass each of them, know the equations, I'll highlight them, that it's np hat and q hat is the equation for success failure. So you have to check np hat and q hat, both greater than 10. And then you need down here the 10% condition, that the sample size is less than 10% of the total population. And so this question really becomes, put the numbers into the equation, and we'll put that over here in a new light purple, where we put 0.52 plus or minus. I'll show you how to get the z-score here in a moment. 0.52 times 0.48 over 25. There we go. There's the math. And here we'll erase this right here because that's just checking a condition. All the conditions are met. To get a z-score, you have to go to the applet or memorize them. We will give them to you on the test. So make sure you know that the applet exists and how to use it. And you want to go to the normal curve and cover the middle 95% of the normal curve. So the way to get the number here is the middle 95%, and that's between, and there's the z-score of 1.96, which is positive or minus, and that's why we're putting in for a 95% confidence interval a z-score of 1.96. Notice it is z-scores because the 0-1 normal curve is z-scores, middle 95% of the curve is covered, and we're covering between, which is the middle 95, hence 1.96. It said 95% confidence. Make sure you do it relative to your confidence level. And all you do now is solve. I always solve for the margin of error first. So you go right here and just solve the equation. 0.52 times 0.48 divided by 25, square root, and times 1.96. Nice job, Noel. And double check the decimals. I get 1.19. It's almost 0.2. That's a big... So what's interesting, since it's almost 0.2, if it was 0.2, which I wish it was, I don't think they're going to give us that much leeway on this. If it was 0.2, then it would be 0.3. Yeah, it's not going to give us that much leeway. There's no way. It did. The plus or minus was good enough that we were able to do it by entering in those numbers. Let's look at what I did. I would carry decimals, but this was basically plus or minus 0.2. And that equals to the interval 0.32 to 0.72. Notice how 52% is at the center of the interval right in here, and then you would go plus or minus 0.2. You go plus 0.2 and minus 0.2. That's why we call it the margin of error. So 0.52, does that make sense to you all right there? That 0.52 is at the center of this interval. And then you go plus or minus 0.2. So that's what the interval means. Now it accepted the rounded version, and that's very nice of it. I would carry your decimals if you're solving this out. And now we have to interpret it. So when we interpret a confidence interval, make sure to know this for the test. This question is the majority of this chapter. Frankly, if you understand this question, you can do it. You really understand the chapter. I am 95% confident that the true proportion of packages that are mislabeled red snapper, see 13 out of 25 were some other kind of fish. So I am 95% confident that the true proportion of packages that are mislabeled as red snapper and are not really red snappers contained in the interval 32% to 75%. So one is 95% confident that between this percent of the packages are mislabeled. And here's the thing, you might say, why isn't it answer C? Answer C says the packages for the study. We know that 52% of the packages for the study were mislabeled. We want to make assumptions about all the packages. That's what inferential statistics is to figure out what's the truth for all the packages. I am 95% confident that the true proportion of mislabeled red snapper packages for all packages that exist is contained in the interval 32 to 72%. And once again, this really comes home to play for the election. I know I talk about the election a lot tomorrow, but when you look at the election results, these intervals right here, and it keeps changing every day. Literally, they update this in the moment. It was 464 earlier, and those are simulations. Here's intervals right here showing you the possibilities of what's going to happen with the electoral votes. Notice the big overlap. That's a lot of uncertainty right there, and it's been overlapped this whole time. So really, we do not know what's going to happen right here. I just noticed something. How is that the case? It's a skewed interval. Interesting. Interesting. It has to be skewed intervals. Both intervals are skewed. Because there is no class tomorrow. Yep. I follow the UT schedule. If you take a look at this right here, that's the center of this interval, which means it has to be something like that, because that's the lower bound of it. And then the other interval is here, and so the peak would be there. Interesting. Data. That's how data do. Just interesting that Harris has a higher bound for the probability of the 95% confidence interval, and Trump has a lower bound, a higher bound, and a lower bound, even though the centers of the intervals dictate otherwise. It's just the way data goes. You can actually see it in the simulations here that it's not a symmetric distribution. It is a left skew distribution. So I want to see what the truth is tomorrow. That's the way to do it. Man, they have such a cool breakdown. Just very interesting. It's like 50-50 on the dot. Oh, it was 50-50. Now it's 46.6 to 53.3. North Carolina. It's just amazing. And here's the thing. This doesn't mean, and so anyone who sees this, it doesn't mean if you have a 62.5% probability or 62.5% of simulations show you're winning, it doesn't mean you win. It just means, so what they do is they literally simulate 1,000 outcomes Simulation, I could show you right here a simulation, like how 538 works. Let's put this in here because people might be wondering this. So we'll do statistics, how simulations works. I think the assignments are so far in the future that people are like, I don't need to be here. And I'm like, no, I'll show you how simulation works. It's kind of neat because it goes into a lot of the topics we've been talking about. So I'll do a simulation right here. And so what you would have is this right here. Get done early, exactly. What you would need to do is, let's say, how big population of Pennsylvania. Pennsylvania has about 13 million people. So Pennsylvania has 13 million people. Let's say percent of people who vote in Pennsylvania. Percent of people who vote in PA. We'll go by USA. 66% of people vote, and there's about 9 million registered voters. So 9E6. Okay, that should be 9 million, and then 66% of them vote. So that's the amount of voters. Okay, my best estimates are about 6 million people in PA are going to vote, with 9 million registered voters out of the 13 million and 66% voting. So that's a good estimate right there. And then you have to say, the problem is we only have estimates, as the camera just goes crazy. We only have estimates of what the truth are. So what you would do is, to create these estimates of the truth, is you would look at, that's North Carolina right there, let's do PA again. You would look at the current polls. So, and historic data is good too, but we should have polls on here. 538 should have the polls. Here's the recent polls. So you'd look at the recent polls, and what you could do is you could have the polls be what you're sampling from. Let's see more polls. Here we go. This more polls from PA. Interesting. You see a shift right there, and then there's that recent poll. So what you could do is you could take this vector of polls, and the vector of polls could be your simulation. So let's go right. I wish I could just take this vector of data. Man, it's a lot to encode. And then you'd weight more recent history on like how it's going to go. So with this right here, +1, we'd have to call this, let's see here. I'm going to have the computer pick. Okay. Sample from the vector. Harris is positive. Trump is positive. Trump is the positive result. Like +1 means Trump positive. There we go, right there. So the positive will be indicating of a Trump. Like this is +2, this is -1. So that's, we have to give some sort of way of looking at it. And let's go right here. And I don't want to enter in too much data, but for this example, once again, I'm trying to remove any bias. I have no bias. Sample from the vector 1 through 15. It's going to pick a big number. Watch it pick 2, and then it's going to be very 6. Okay, we're going to go back to 6. Then you have to put some weighting to the, here we'll do recent matters most. Poisson rating. So Poisson distribution weighting. And so Poisson, so it's 6. Let me ask ChatGPT. Go to ChatGPT here. I have 6 elements in a time series and want to weight them by most recent occurrence to have a 100% weight. Give me a vector in R that would assign these weights and probability of selecting them based on time series weighting. Okay, see what we got. Elements, weight, okay. Interesting. Okay. So there's the weights. See what it turns out. Discord. Okay. Weights n equals 6. I don't know the rev. It's reverse, right? Just reverses the sequence. Okay, cool. It's a very, very exact. Let me go round on this. Round weights 1 digits or 0 digits. There we go. Sum of these, do they equal 100? 101, of course. Let's go right here and say to it, subtract. Whoop. From first, subtract from last. Subtract from last. Okay. So weights store into. Did we overwrite? We didn't overwrite. Doing a simulation. Weights overwrite. Weights rounded. Oh, and it's called weights. Weights comma round weights to 0 digits. No. There we go. That's right. Unexpected comma. Oh, previous line of code. There we go. Weights element 6. Delete from element 6. -1. Oh, weights element 6. There we go. And now weights, or some weights. Whoa, that's bad. Oh, I know why. Minus, wait. That's right. Weights element 6. I don't know how I broke that. Weights divide by 100. Store into weights. Okay. Now we need the outcomes. Where's the outcomes? Are you having fun, Noel? This is fun for me. -1, 2, 1, 1, 2, 2, 2, 1, 1, 2, 2. Okay. Outcomes. -1, 2, 1, 1, 2, 2. There it is. Yeah, so this is how I'm setting up the full simulation here. Trying to do it in a way someone would actually do a simulation. Sample from outcomes, comma, probs equals weights, comma, place equals true, comma, 1 outcome. There we go, okay. And we're almost done. Almost got the simulation. And 10,000 simulations. There's the 10,000 simulations. Outcomes. Or no, we don't want to do that. We're going to do this. Simulation. There's the simulation. Once again, we could be doing this like with more like weighting each poll based on how good it is, weighting it on time series. So yeah, we only have those results right there. And then what we could add to it is we could add to it some fuzzifier. So we could add, I don't know coding, but I need to learn some basics from a magic class, so I'm not sure where to start, so it's really good. Yeah. So we could add to each simulation randomness. And so simulation, and then we could go to it plus random, or rnormal. It's gonna make like a trimodal distribution, and rnormal 10,000 observations to it with a mean of 0. We don't want to bias it, because if you think the polls are wrong in one direction, you could bias it, but we're not going to bias it. And standard deviation of 7.2. And there we goes that. And now let's write simulation 2. And there's our simulated results of now. There's that. There you go. There you go. There you go. So there's the simulated results, like they're getting simulated results. And so what I could say is we go back to ChatGPT, which is going to, this is, let me go here. I've created the following distribution of simulated results. It's a numeric vector. Use ggplot2 and other techniques to shade the histogram when it is below 0 as blue and above 0 as at or below when it is sure, right? I don't want any bias. Sample from the vector at or below, at or above, at or below. When it is at or below 0 and above 0 is red. And display the simulated probabilities on it as, I don't care what. So setting the mean to 0 will kind of, I'll explain that here in a second. Kind of. Then display the simulated probabilities on it as Harris has a Harris wins in insert percent that are at or below 0 simulations, and Trump wins in insert percent that are above 0 simulations. I put that thing there. Okay. Pretty crazy. ChatGPT is just absolutely nuts what you can do. It's doing its own simulated data right there. The ggplot looks pretty good though. It's making its own simulated result. We don't need those. Like it's doing its own simulation. Mean simulated results. Okay, good. So we need this code because that's going to tell us what percent are below. So it's calculating that, which thank you for the comments, ChatGPT. So that is, we'll grab the whole thing. Then I'll delete what we don't need because it did things we don't need. You just have to know what the code's doing. And I should have ggplot2, should have dplyr for data manipulation. And we do not need the simulated results. So we're going to, because we already have ours. Notice it calls it simulated results. So we can do a cheat right here where we can store our simulated results into simulated results, which will make the code easier to use. And so we're just overwriting. That way, everything down below is our code also. Now it's finding out the percent that are at or below 0 by taking how many simulated results there are, doing a logical check to see at or below 0, times it by 100 to turn to a percent. There's the percent below 0, 36.6. And here's the percent above 0, 40. Oh my gosh, what's wrong with my mind? 63.4. There we go. I can subtract from 100. And then making a data frame of the results. Sure. Just storing it there as a data frame with the vector inside of it. Then using geom_hist. It didn't use other things, but used geom_hist. Ooh, that text is a little bit high. So now we got to change the text location. We don't want, that is, there we go. It looks like a cool thing. And we got to change the text size. So we're going to have to bring the text size down to like 2, text size down to 2. The Y location is going to have to change. So we do not want the max of the table. Breaks is another argument. Y equals, where's the Y equals ending? Okay, that's right there. And then we're doing a plus on the end of this. Oh, that's kind of there. We can manipulate it with this, right? There we go. That's what I'm talking about. Okay. Nope. Too low. And then the X location. Harris's needs to go 3. Trump needs to be over here, symmetrically that way. So now we've kind of created, how's this looking, Noel? There we go. We'll bring Harris down a little bit more. That's touching the graphic now. There you go. That's our simulation. And I'll talk about setting the mean right here. But this is, if I were to put this on, once again, this is simulations. It doesn't mean that one person will win or won't win. It's just simulation of possible results with randomness added on and creating the distribution. You can kind of see the peak, or maybe I'm just imagining things around -1, which was the original data point of simulation. And kind of see it. So yeah, I mean, simulating what is possible and adding random noise onto it. Yeah, because, yeah, and that's what you'd have right here. That's how you would create this sort of thing that uses poll results, as they've done here on 538, and, create some sort of probability analysis. Does it based on the data inputted on each day? Yeah, so what they're probably doing is these polls right here are, and they also give a rating to each poll. That's the way 538 will often do it, is they'll give a rating to a poll. And usually I see the rating, but they're rating each poll as a quality, and they give the higher the quality of the poll, the stronger it'll have. So my guess is, this is what I guess and what I believe is going on, is there's the recency of the poll, there is the quality of the poll, and then that would go to the weight in the model. So then the code back here in the background of this is going to create this weight vector, and the weight vector is created right here. You can see my weights for most recent is always going to, like, you'd never look at a poll from July right now to be like, what's going to happen in the election, because a poll is only a snapshot of what's going on, and the more recent snapshot and the closer to election date of the snapshot, the more relevant to what will happen. It doesn't mean it will happen, it just means it's better information. The most recent information, especially for polls, is the most best. Sure. Excuse me. Excuse me. But with this, now the bias thing, so you got to be careful here, is setting the mean to 0 and standard deviation to 2. You think about what a standard deviation means, is I'm adding on around 2 to 4, maybe sometimes even as big as 6, plus or minus, because there are margins of errors in these polls. So I've basically said with 95% confidence, these poll results are within 4 of the error, because 2 standard deviations, this actually gets back into our talk, 2 standard deviations would be plus or minus 4. So if I'm saying the margin of errors on these polls is 4, a standard deviation of 2 kind of makes sense. So if you get a poll Trump +1, it could be Harris +3 or Trump +5. If you get a poll Harris +1, it could be Trump +3 or Harris +5, because you're uncertain. Now, what you would do is, if you thought polls were biased, you would add in here like -3 if you want to bias it towards Harris, because that's going to make it so the random number picked is closer to -3, or that's the most common random number picked, because that's the mean of the distribution of random numbers being selected. If you want to make a bias towards Trump, you would pick +3. That's only if you believe there's good reason to believe that the polls are biased. And I'm not saying they are or aren't. It's just you have to be careful, because if the polls are real, then you put 0 bias. If the polls are more biased, you put bias in one direction. But what if some polls are biased and some polls are not? It's just tough. I don't do polls. And that's where the mean of it, the standard deviation is the spread of it, and that should be accounted for in the margin of error. So I think this is a pretty good simulation of what's possible. And I always say to people that, obviously, and because Hillary Clinton, especially her results, are a great example of like, well, wait, it said she had like a 23%. Off the top of my head, I think it was 23%. Watch, let's see how close I am. My memory serves. It's either 23 or 27. I have both those numbers in my head, but I think it's 23. So Hillary, Trump, 538. And here's the election night for 538. It was 71. So it was 71, because Trump had a 28.6% probability of winning, and he ended up winning. And this is within the simulations. And I'm glad they say simulations now to let you know it's simulated results. And so my question to people always is if you had a 28.6% chance of winning $1 million, would you be excited? And they're like, yeah. And I'm like, well, that's what the probability was for Trump to win the presidency. And we're like, but that's not likely. And I'm like, 28.6% is something that can occur. It's not a very, very unlikely occurrence. It's not even statistically significant with 0.05% probability or 5% probability, 0.05 p-value. And so it's tough for people sometimes to understand that unlikely things happen all the time, and something that happens 3 out of 10 times almost is not very unlikely. It's the less likely event, but when it comes to unlikely unlikely in statistics means 5% or less. And even then, we have type 1 errors in statistics. It's the unlikely event right now is RFK wins. That's as far as I can tell, not happening, statistically speaking. And the unlikely events also via their simulations, if you look at what they have going on right here, is the unlikely events are like no winner. No winner happens in 2 simulations. So, I mean, it could happen where there's an electoral college tie. So it's just a guess, but not for certain. It's something we can say that shows us the probabilities. And here's the thing. There's a simulation where Trump wins 481 electoral college votes. That is, I don't know if anyone's ever, I think, was it Reagan had a huge victory? I don't even know if Reagan got that big of a victory. I think Bush, his re-election, had a huge one against Kerry. Like, he got the 300s. I think Reagan, I don't know if anyone's hit, someone might have hit the low 400s. Ooh, no, I think there was one election that might have been, I think it might have been, dude who, Roosevelt. I think Roosevelt might have carried like high 400s. So, like in his 3rd term or something ridiculous, you know, like, because before we had the amendment that you can only have 2 terms. But there's a simulation also that, I mean, you just got to think, like, there's a simulation where Harris wins 496. It is theoretically possible that Harris wins 496. It's theoretically possible that Trump wins 481. Just theoretically possible. I mean, it's theoretically possible also that they win all of them, but no simulations show that possibility. The more likely occurrences are in here. The more likely events are over here towards the middle. And it's more likely that we'll see like narrow victories if you notice where the peaks are. So a likely thing for Trump tonight is 312. Like, that's the most likely. The most likely thing for Harris is 308. I mean, but there's a lot of very similar likely events. Or not tonight, tomorrow night. It's so soon. Then there's also this spike for Harris over here where she's got, and spike for Trump over there. It's just one simulated electoral. Oh, that, yeah, of course I know that. I thought it meant like there's one over there and that's the no outcome or the no winner. So, you know, it's just going to be, oh, there's the no winner simulations. We can't click on them and see it. But I didn't even notice that bowl at the top right there with the no winner. It's going to be interesting. It'll be interesting. How can they know the result on the day of the voting? So we probably won't know the result on the day of voting because, especially with absentee ballots, and then they have to certify a lot of votes. So you're going to see, especially, and there's the rating of the polls right there. So Patriot Polling has a 1 star, where something like Hart Research has almost 3 stars. Emerson College has been around for forever. They have one of the highest ratings right there, and they're saying it's completely even. Emerson College is very, very highly rated. Interesting Patriot Polling. I'd like to find out about them. Just like it would seem. So here's their polling about us. There we go. There's hello, random guys. Interesting, but they only have a 1.1 star. 1.1 star, and so we'll have a good understanding of what the results are. And also, this is why on election day, if some polling areas haven't reported, we can still call it if we have a good reason to believe that it won't overtake. So they have called things early. It has happened. But it's when we know kind of from historic data that there's pretty much no way. And even then, in personal opinion here, is we should always count every single vote. That's what we should always, the vote should always continue. Every vote should be counted. That's the way it goes. And certify the results. That's the way it goes. You get all the votes. But look at this. This is over 50. What's 50 and 51%? What is going on right there? So it's just the way it goes. That just cracks me up. So I know, right? And once again, we're not really expressing any political opinions here, but it's just some people have wondered, how can a state be called? It's, put it this way, like, let's say Tennessee is virtually tied, which it won't happen. Tennessee's virtually tied. And the only county, Tennessee's not virtually tied. We know the historic data for Tennessee. It's really cool if you click on a state, you can look at the historic data for each state. A lot of people don't know how to read the graphics because they are somewhat complicated. There's the simulations. We don't even have one simulation over there. It says one, but there's the polling rates. So there you go. And here's the historic data for Tennessee. Al Gore was from Tennessee in 2000, so that's why that's really close. Tim Walz and Harris are not from Tennessee, so I don't imagine being any closer. This is the national average right here. So you see nationally, Bush was the last Republican to carry the national average. But the national average right here with Obama re-election, Hillary and Biden, the national average has gone this way versus Tennessee has gone more Republican. And so with a plus 20 Republican, I do not see in any way that we'd be virtually tied. So we could talk about, let's talk about a state that is virtually tied right now. So a state that's virtually tied, as everyone knows, is Pennsylvania. And so the way this goes is, and especially looking at historic data right here, you can see Trump carried Pennsylvania in 2016. Trump did not carry Pennsylvania in 2020. And the way this goes is if you have Pennsylvania and it's a complete tie, but you have a bunch of the cities have not reported, and the cities have historic data that goes towards the Democrat, which a lot of cities do, then you would likely call it for the Democrat. Now, once again, every vote should be counted. But that's why they often call things when they say, okay, we know here's where we're at, and these are the votes we don't have in yet from these areas with only certain amounts of the precincts reporting in. But if you were to have more Republican stronghold areas, precincts that have not reported in for Republican strongholds, and then it's a virtual tie, you would say, okay, wait a minute, the outstanding votes we know come from Republican strongholds. The precincts are going to go this way. So even though it's a virtual tie right now and it looks impossible to call, 80% of the outstanding votes are from this area. So we're going to see a large swing in this direction. It's just statistics. It's historic data. Once again, none of my views on politics matter here. It's just that's how they call things. People don't understand when it's a tie and they're like, it's going this way. It's because we have the historic data. It's that we know this area votes 80%, let's say, in one direction. And if it's like this, we know it's going to shift this way. It's just data. And people say, how do you know that? It's like, well, if I had to tell you, like, if you wanted to bet with me tonight, I will take a bet. I will bet California goes for Harris. I'll bet Tennessee goes for Trump. And I'm not here to make bets, but this one's got an even lower rating right there. It's a 0.7 star. That's wow. I want to find a 0-star pollster. Like, why are you including that? And yeah, that's just how we use data to make decisions. Historic data guides our decisions, and even the recency effect. Because if you go far back enough in time, like if someone said to me, Brian, I think Tennessee could go for Harris tonight because we almost voted, it was close in 2000. I'd be like, that's 24 years ago. And also there's variables you're not taking into account that Al Gore was a Tennessee senator. So the representation, and also he was an incumbent. Well, so Harris is VP incumbent too. So okay, you've got that similarity, but recency and extra variables, lurking variables that you're not accounting for that would account for the difference. And I wish it showed even further back. I wish you could just expand that. But it's just really fun to me, especially to look through the data and see. I really like the time series of each. Wow, that's the national. Even California, Bush came the closest. Bush re-election came the closest. They didn't really change much from 2000 to 2004 though, and then they've broken more Democrat. Texas, some HEB. There's Texas right there. Texas is becoming a little more blue. It had the dip back here. So that's Obama re-election. He did lose some ground, especially on the national. So you see that dip is actually, so what's interesting is the go against the pattern here for Texas, where Texas went more blue and the United States went a little more red right there. So that's interesting. And then this increase is the same. The lines going against each other is what I find interesting, where you see the lines parallel here at the start of the series. I mean, almost virtually parallel. 2016, I do not know why Texas had a shift. So that 2012, I'd have to ask Texans, what's going on here with the shift in the data? You see shifts in other ways with other states like Tennessee, of course. How do we not follow the national pattern? We're going, you notice, it goes down, but that's a bigger dip down. You notice the small dip right here versus Tennessee has a big dip. We have a small, but that might be a recovery from the big dip. North Carolina, I just love data. I mean, I could look at data this big '08. Yeah, which is last time they went Democrat. '08 is such a huge, if you notice this jump, still a pretty big jump. No, there's a bigger jump though. If you notice it, this goes about one length, that goes 1.25, which is a 10%. So that's about a 12.5% jump to a 9% jump or so. And then it follows the national pattern. A lot of things follow the national pattern. Florida, used to be more of a swing state. Florida right there, virtual tie 2000. Florida is going more Republican. You can see it. Notice how national, like it goes down and then it went back up here, but Florida went more Republican. So Florida did go for Obama and followed the pattern. It basically had that same jump, same little dip, less of a dip, unless there's more of a dip in the national. And the same dip there. And then when the US went back this way, Florida went that way. So I don't know. What are your thoughts on data, Noel? Arizona. So here's Arizona right here. Following, they did not jump in '08. So they did not follow the national pattern. I stayed, and then they've been back on the rise, but they're predicted to go Republican. They've been back. If we say they've been back going blue right here, I think it's pretty cool. Yeah, exactly. It's very interesting. And to see, the thing is like, if you look at these graphics, anything's possible. So it's my thoughts on it is anything's possible. Minnesota. It's all possible. Polling averages, that's outside of a margin of error right there. Fundamentals only forecast. So these are different forecasts I think they're talking about. Is that Minnesota? It's the power of the incumbency. So it's being an incumbent is a big thing. Probably why Democrats were thinking of running Biden, because just we're talking a little history of politics now. Incumbency is considered, of course, Trump lost as an incumbent, so Biden could have lost as an incumbent too. Just that's something people in politics consider, is that if you're an incumbent, you have a more likely probability of winning. It's just shown in historic data. And so we'll see what happens. No opinions, just the facts. Let's go down here let's go to Oklahoma. My gosh. Could you imagine? It was like 80%. Pretty crazy. I mean, just the extremes. I like the extremes. I just like seeing like what is the craziest thing that could happen. Really, which margin of error forecast only? You look at Oklahoma, I guess it's just a Republican, like very strong Republican right there. So really hasn't changed much. It stayed at around 66% or so. Alaska, Hawaii. I didn't know. I don't know the views of every state. It's very interesting. Whoa. Wow. So Oklahoma and Hawaii are drastically different. So very, very different. That is one of the biggest jumps I've ever seen right there. Yeah, that change right there is huge. So Hawaii used to be not 50-50. Hawaii used to be, 54 is, it's not quite a swing state, I'd say, but so they were like, evenish, and then boom, they jumped to 72%. And then they've been dipping down a little bit, but I'd say going back towards, because 72%, that's whew. Is there any stay with bigger jumps? Oregon. I just love looking at data. Yeah, that's another big jump right there. Oh wait, is that only? No, Hawaii had a bigger scale to it. So it looks like a bigger jump, but the issue is the scale of the graphic is not the same. So Hawaii is almost plus 50. That's insane. The problem is the scale up here is not the same. So we're like, oh, that looks about the same size jump, but it's a bigger jump because it goes from plus 10 to plus 47, 46 or something like that. And so you have to think DC is a, look at, wow, that is insane. I mean, that's as far as it goes. Oh, wow. Yeah. So that's, yeah, I mean, That's, man, that is, wow, 92.1%. That's, wow. I don't, that might be the most extreme, like on one side. So, Rhode Island, Maine, is that me? Michigan. So bad when it comes to states. Maine's all the way up here, right? Massachusetts. How did I not know that? I'm still working on my first coffee today. Massachusetts. And then there's Maine. I was like, Maine's all the way at the top. So Michigan right there with the Great Lakes. I'm not here to teach you states. I'm here to just look at data. Doesn't matter what's called. This MA right there. MA. Right there. Yeah. Well, that's the data. I don't know. What's the last thing? We'll see if it updated here. Over here, what do we see to start? Show me my simulations. Yeah, I think it's updating. I think we saw 46.4. So they're updating like as it goes, getting more polls in. We made our own simulation right there for Pennsylvania. So we could fix the graphic a little bit. Here we go, simulated PA results. Nice per graphic. So there's our simulated PA results from most recent data. And doesn't mean it'll happen. And here's the thing, if you redo the simulation, you'll get different results. So I think we have everything set up properly. There you go. 36.5, 36.3, 36.4, 35.8. We actually got one of the highest results for Harris. 36.8. Use that one. There we go. 35.7. Simulations are randomness. So that's how you can do a simulation. And then you have it keep updating. Your code just basically pulls the most recent data, runs off the most recent data, weights the most recent data, puts value on certain pollsters more than others, ones you trust versus you don't trust. And that's how you run a simulation. You just have it keep grabbing the data. That is how we do simulations. And you could then create these graphics, make them look all pretty for each state. And then you predict based on this who's going to get the Electoral College. Then you simulate the Electoral College. So you do a simulation of your simulation. So then you have it draw from these results if somebody wins that state. And then you simulate the Electoral College from the simulation of each state. Does that make sense, Noel? So your simulation leads to a simulation. I love it. It'd be fun. I don't know, maybe another life I'd be working for somebody doing simulated results like this, but it's possible. Like if you gave me a week, I could maybe make a website for predicting, because all I'd have to do is make a bunch of I don't know, I could maybe do it in a day thinking about it. All I do is just, the harder part is grabbing the most recent polls and setting that up to be automatically done so that someone's probably entering in an Excel spreadsheet in the background and then they're just grabbing that and then it's, yeah. So I could probably do it in a day. If you said, Brian, I'll give you $1 million if one day you can make your own 538 website, I think I could get that. So someone challenge me on that. Be like, $1 million. I'll make, not a student. I don't want a student to do that. I'm just like, it's just, all I'd have to do is, I'd have to, yeah, exactly. I'd go to G Sheets. I'd make a G Sheet of all the polls for each state. So that way, and then the G Sheet would read in what state it is, what the poll is. I put in a rating for each poll, and then the recency of the vector, where it would compute that. And then you could click on, so then it'd be the website would be from a Shiny app, and you would click on the state you wanted. I wouldn't have the cool, might be hard to get the map. I don't know how to do the map. I could have you just select the name of the state or from a drop-down menu or something, and then it would show you the simulated results for that state. I know how to do that. And then you could click on the national and it would just simulate from this. Like all I do is just pick from there, from Harris wins PA, and there's the associated probabilities. And then it would just simulate it. And then I could make the distribution of Electoral College votes from the simulated results. Wouldn't be that hard. It just, I don't know, wouldn't take that long. So let's got it. I like this stuff. It's, if you can tell, what we try to do here is usable so that you could create your own 538 website, teaching things like simulation, probability distributions, is basically a normal distribution, and it's not centered at 0. I should find out the mean of the distribution. Mean of simulated. There you go. 0.8. So that is the predicted difference in PA. We'll see if I'm right tonight. Could be very wrong. Once again, that is the predicted difference with a standard deviation of 2.3. So here it is. To end office hours. Oh, this is good. Start where we ended. Oh, we gotta do 2. What am I doing? I don't want 68% confidence. Okay. Stats person just came in and said 1.96. I say 1.95996. Okay, there we go. And then minus. Okay. For tomorrow, I am 95% confident that the true result of Pennsylvania will be plus 5.4 Trump to plus 3.7 Harris. I am 95% confident. 3.8. So Harris wins by 3.8. Trump wins by 5.4. I am 95% confident. That's only 95% confident. I want to go 99% confident. I am 99% confident. Sorry, I'm not using T, that person. I'm using Z's because I know them. I am 99% confident that the true percent of vote in PA will be contained in the interval. Trump wins by as much as 6.84. To Harris wins by as much as 5.22. It's a pretty wide interval. Well, there's my confidence intervals on what could happen based on the 538 recent results. We chose that to start right here to not be biased. We chose a vector. You can look back at the code we ran right here, where it was at the very start of the video. I asked it to sample from which will be the positive or the negative, and it chose that right there. So this code right here chooses for me at random. And so when we ran that to not be biased, I was like, it's just the interval has to be set up in some way that one person has the positive or negative numbers. So when we did the simulation, we had to enter in the vectors this way right here so that we could simulate the results and figure out. So we let the simulation pick for us what we were going to do when it came to any sort of choice where I felt like someone could be like, wait, you're biased. I don't got any bias. I'm just doing code. I'm just showing you how I'd work for 538 and try to do this right here and take from it. And then even it's like, well, how much data did you input into it? I'll let it pick because I wasn't going to sit there and enter in every single value. I said, pick for me how many recent results I'd go through. And it said 6 right there. So I said, okay, I'll pick the 6 most recent results. If it said 1, I would have said, I shouldn't have put in 1. I should have put in 5 through 15 or so. 1 we wouldn't have been sampling. We would have been sampling 1 poll. So, that's not going to be a good simulation. But with that, it was a lot of fun. It's I think it's interesting to know how simulations work because that's what we teach in our class, and to think about how companies are using simulations to see possible results, because that's all we have right here is possibilities. And that's what confidence intervals tell us is kind of what is plausible. Doesn't mean everything would be inside the confidence interval. It's just we have a certain confidence level related by the z-score. So when you go back here to the mathematics we were doing on the first problem, the z-score for my first confidence interval was 1.96 that I just computed, 95% confidence, versus the z-score of 2.5758 for a 99% confidence, 2.5758. And I'm using z-scores. Yeah, it is proportional, so I am supposed to use z-scores. So more on that with T's and Z's and William Gossett and the normal and the Gaussian. It's normal. But until then, bye for now, everybody. Bye. Bye, Noel. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.